Welcome back to my channel. So this video is something based on Boolean logic. So I'll be explaining some examples on how to convert a Boolean expression or a Boolean function to corresponding logic circuit. So let us go into the video. Some examples of how to convert a Boolean expression or a Boolean function to a logic circuit and vice versa. Okay. So first example is f equal to x dash y dash z plus x dash y z plus x y dash. This is OR operation. Okay. So let us see how to do this. So there are three Boolean variables. So they will be considered as inputs. So first we shall write x, y and z. Okay. Then here first we will consider this one. So we have to find x dash. So how can we get x dash? By providing a NOT gate. This is NOT gate. So what is the function of NOT gate? It will complement the Boolean variable. So after getting into this NOT gate, what happens to x? The output will be x dash or x bar. Okay, then we need y bar or y dash. So I will be providing another NOT gate. So here it becomes y dash. Then we have z. Okay, let us see whether here we have z dash. If there is some z dash, then we can provide a NOT gate here also. But here in this question that I have given, there is no z dash. So we can simply write like this or draw like this. Okay, so first one is this, that is x dash y dash z. So here it will be x dash, here it will be y dash and z. So what is happening to this? These are being AND. So we have to provide a AND gate. Okay, AND gate. This is how you draw an AND gate. So AND gate is done. And next, x dash, y and z. So this is x dash, right? So we'll be making a connection from here. And we need y. So y is from here. This is y dash. Okay, this line is y dash. We need just y. Okay, we are taking from here. Then z. Z also we can take from take a connection from here. So what is happening to these three variables? That is, one is x dash. This line is x dash. Then y and z. These are again performing an AND operation or AND gate. So we have to provide AND gate here. Then again one thing is here x y dash. That is x, we can take it from here. Yes, we can take it from here. X, then y dash. So this is y dash. Okay, here this line is y dash. So we can take y dash from here. Okay, so this line is x and this is y dash. So these are again and this is again an AND operation here. And what is happening to these three things? These are being ORed. This and this and this. Okay, so this is the first thing and this is the second one and finally this is the third one. So all together I can draw like this. I can make it closer and these are being ORed or operation or OR gate. So this is the final output. Now why did I make a subdivision? Like first we have to perform this, then this and then this. Why did I do like that? And then finally I perform the OR operation. So why did I do like that? This is because we have to follow the preference. That is, first is NOT, then AND and finally OR. So this is the priority of operators. So first we have to perform the NOT, then AND OR. So let us see whether there is and or. So here we can see that there is and operation here. So first we have to perform this. Then we can see here that this is another and operation. Again here another and operation. So first we have to finish off these three and operations, and after that only we have to check for or operations. Fine? Okay. So this is how we do the first problem. Next we will move on to another. So I'll just write the output from here. This is x dash y dash z. Okay, x dash y dash and z, and this is I can see from here that is x dash. Yes, we can check whether we are doing the correct thing. Okay, then this input is, we can see from here it is y. Okay, and this is z. Okay, these are being and, so x dash y z. Yes, this is correct. And what is the output from here? Let us see. Yes, this is x, and this line corresponds to y dash. So x y dash, because this is and operation, that is why like this. Okay, we can either put a dot operator, or instead we can write it like that only without dot operator also. So that means and operation. Without dot operator it means and operation. Okay, then these three things are put into the OR gate. What happens finally? F is this one. Okay, hope it is clear. Let us move on to the next example. So if you have a doubt after writing or after drawing the logic circuit, you have to check. You can check the output from each gate, and we can check whether it corresponds to the final output. Okay, so we will move on to second one. So the second example is A bar B. This is a simple example, A bar B plus BC. Okay, A bar B plus BC. So we can see here that there are three Boolean variables. So A, and we have B, and then C. So A is being not here. Not is performed. So we have to give a NOT gate to A. This is A, B, and C. Okay. So first we have to do this one according to the priority. So let us see A bar B. A bar B. So this is A bar and this is B. So this we have to give a AND here, because there is AND operation. So a dot is there, or else we need not provide a dot. Both are same. A dot B is equal to AB. Okay, either we can provide a dot operator, or instead we can write it like that. Both are same. Okay, so that is done. So the output will be A bar B and B C. Okay, so we need not give another B from here and then perform AND. Instead what we can do is, we can take a connection from B. So yes, from B I am taking a connection and I am providing AND, because here AND operation is performed. So the output will be BC. B from here and C from here. And finally what is happening? These are fed into the OR gate, because it is plus here. This and this one. Okay, A bar B and BC. So between them we have an OR operator. So we have to give an OR gate here. So what will be the output? F will be A bar B. Okay, A bar B plus Y plus, because it is OR gate, and BC. Okay. So this is also done. Now next we will move on to another example. This was somewhat an easy example. Okay. So next let's move on to another example which is slightly confusing. Okay. A plus B dash bracket C dash plus D. Okay, C dash plus D. So here we can see a bracket. So let us see according to the priority. So here we can see that plus is here, but there is a and between these two things. Okay, between a plus b dash and c dash plus d, there is an and. Here there is an and. So here it is not given as dot. They have simply drawn two brackets. But in between this, what is happening? These are getting and. So according to priority, we may think that we have to perform this thing first, and operator. But there is a mistake, that is we are given a bracket here. So whatever happens, if there is a bracket, we have to first solve the bracket and then go to not, and or. First we have to finish off the bracket thing first. So let us see, this one we have to finish and this one we have to finish, and after that we have to perform and between these two things. So let us see how we are drawing this. So there are four inputs, as you can see, A, then we have B, then C and D. Okay, so A there is no not, but B there is not. So let us draw a NOT gate here. Then C also there is a complement happening. So this is how we draw the initial things. Now A or B dash, because this is inside the bracket, we have to finish off that first. So A and B dash we have to OR, because it is plus here. Or how will we draw the OR gate? This is how we draw the OR gate. Then C dash plus D, or C dash or D. So this is C dash, this is B dash. Okay, okay. C dash and or D. C dash or D. That is C dash or D. This is how we call them. Okay, C dash or D, or C dash plus D. Better it is to name it as OR. Now, finally, what is happening? These two things we have to perform the AND, because there is a dot in between them, or if there is no dot also, it means there should be AND between these two components. So how we draw the AND gate? This is how we draw the AND gate. Okay, now let us check whether we have done the thing correctly. So first, if I am not marking it like this, let us see. Okay, so after each logic gate, you write the output from them. I repeat, after each logic gate like OR, and NOT, you have to write the output from them. So first we shall see, yes, this is a NOT gate. So after NOT gate, the output will be B dash. B is the input, so output will be B dash. And C will be C dash. Now let us see this. Yes, this is an OR gate. So OR means plus. So A, that is here, the input is A, and B dash is given to the OR gate. So what will be the output? A plus B dash. Now let us see this. This is D and this is C dash. So the output will be C dash plus D, or C dash or D. And what happens here? And. So this is a single thing and this is a single thing. So these are the inputs to the AND gate. So what happens? Finally, A plus B dash, a single thing, and C dash plus D. Either you can write a dot or you need not write. Both are same. So yes, this is same as the given thing. So this is correct. Okay. So after each logic gate, you can write the output and cross check with the given question, so that you can be sure that you are correct. Right. Okay. Let us move on to next example. Fourth one. The question is A plus B plus B dash into A plus C dash. Okay, this is a question. Fine, let us write. Okay. So there are three Boolean variables, so we can write it like this: A, B and and C. So let us see whether there is in bracket. Yes, we have got a bracket here. A or C dash. A or C dash. So A is here, C dash is here. Okay, so we found that they are bit like they are A is here and C is here. Right, in between we have B. So it will be difficult for us to draw. So it's better to mark it as C and this is B. So that we can finish off this thing first. Because there is a bracket. So we have to give priority to the bracket. Then only we can move on to the other logic gates. So A or C dash. So C dash means there should be a NOT gate here. Yes. So A and C dash are being ORed. OR gate should be here. So the output will be A or C dash. Then we saw that we should look for AND operations. Yes, B dash and this thing is done. Okay, so this is the output and we have to AND it with B dash. AND it with B dash. So B dash means we need a NOT gate here. So let us draw it like this. Okay, so what is happening to these two things? This is being AND. So yes. Okay, so what will be the output from here? It will be B dash because this is B dash, right? This is C dash. Okay, B dash and what is being AND with B dash? A plus C dash. Okay, A plus C dash. Okay, so that thing is over. Now AND operations are not left. There are no other AND operations. So we will move on to OR operations. Yes. So A and B are being ORed with this thing. Okay. So let us see how it is done. A. Yes, where is A? Yes, here it is. So A or B. A or B. So we can see it like this. It is A or B. Okay. A or B. Okay. Then again an OR is here. So again you can write it like this. OR. That is A plus B plus B dash A plus C dash. These two things are being ORed. Fine. Hope it is clear. Okay. So another way of drawing this thing, that is this thing we can redraw as, this is one method. Okay. Either we can draw like this or we can draw another method. That is, these three things are being ORed. So we can directly draw like this. Okay. Directly we can take A from here, B from here and this thing from here. These are being ORed. Okay. So what will be the output? The output will be F. Now let us cross check. Let us cross check. Okay, so let us cross check whether we are correct or not. So this is C bar because from not we will get C bar. Then from here we will get B dash. Then what is being ORed? A and C dash. Yes, so A plus C dash. This is a single thing. Then what's happening here? Yes, AND. What is being AND? A plus C dash and B dash. Okay. Then here what is happening? These three things are being ORed. What are being ORed? A, B, that is A plus B plus this thing. Okay. A plus C dash into B dash. So B dash can come here or here. There is both are same. Okay. B dash, either B dash can come here or this is equal to A plus C dash into B dash. Both are same. Okay, fine. Yes, this is another method. So in this case, In the previous case, what happened is that A and B, for A and B we created an OR gate here, and again we needed a OR gate here also. So, but in this case there is only a single OR gate used. Okay. Now let us see another example. Let us move on to next example. Let us, we are using Xor gate here. So how we draw the symbol for Xor? Plus and a circle. The whole bar plus B. Okay. A Xor C, the whole complement plus B. So there are three inputs. So let me draw like this: A, B and C. This is usually how we draw it. But we can see here that there is a bracket. So we have to give priority to bracket first. So what is inside the bracket? A and C. So it's better to write C here. You can write it anyway, but the output should be same. So A and C are being XORed. So how we draw the logic gate for XOR? Like this. This is the logic gate for XOR. And what is happening? So this is the output will be A XOR C. And what is happening to this thing? This is being negated or complemented. So there should be a NOT gate here to complement them. So A XOR C, the whole complement. Okay, then what is being ORed with this thing? B. Okay, so B I am taking from here and I am just putting an OR gate here. Because this thing and B is being ORed. So the output will be same. Now let us cross check. Okay. So what happens when we cross check? Let us see whether we got the same thing. So here A and C are being XORed. So A XOR C. Then what is happening to this thing? It is being complemented. So it becomes bar. Then here B is coming. The output will be A XOR C, the whole bar plus B. Why plus B? It is OR gate. So let us see whether it is same. Yes, it is same. So our answer is correct. Okay. Now let us go to next example. Last one. This is also an example for XOR gate. A bracket B XOR D close bracket and plus C dash. So here we can see that there are 4 Boolean variables. So let us draw like this: A, B, C and D. Now let us see if there is a bracket, because we have to do the bracket first. We have to perform this thing first. But we can see here that B and D are apart from each other. So let us draw it together. Okay. Yes. So I am drawing an XOR gate for these two inputs. And we can see that there is an AND happening here. So we have to give preference to AND, then after that only we have to perform this OR. So what is being AND with B XOR D? A. So let us take A from here and provide an AND gate between them. Okay. Now finally we have to take C dash. So there should be a NOT gate between this. Okay. So the output will be C dash. And what will we have to provide here? Which gate? It will be OR, because it is plus here. Okay. Let us now cross check. So B and D XOR. So B XOR D. Then A is coming from here. Yes. So A is being AND with this thing. This is a single thing. This is a single input. So A and B XOR D is the output from this gate. Then from C, there is a NOT gate here. So it becomes C dash. And finally, what will be the output from here? A, B XOR D plus C dash. This is the output, final output. Now let us cross check with this thing. Yes, this same. So our answer is correct. This is how you convert a Boolean expression to Boolean logic. Or if you are given a Boolean expression to Boolean circuit, and if you are given a Boolean circuit also, we can convert it to Boolean expression. Okay.
So that's all for now. If you have any doubts, please comment in the comment box. Thanks for watching my video.